Right. Good afternoon, everybody. Thank you so much for joining us for our EI Live K-12 session for students and educators. My name is Cassie, and I direct education and outreach activities for the Earth Institute. For those of you who are joining us and who aren't familiar with the Earth Institute, our core mission is to foster a greater understanding of the science behind climate change and sustainability and what we as global citizens can do. The Earth Institute is actually made up of 24 or so research centers and several hundred people who work across many different disciplines and departments at Columbia University. And experts that make up the Earth Institute include earth scientists, economists, business and policy experts, specialists in public health and law. And so it is truly an interdisciplinary research institute. What we're hoping to do with these EI Live K-12 sessions is to introduce you to some of that work through scientific experts. We have weekly sessions until the end of June. And if you'd like any additional information about those upcoming sessions, please do not hesitate to contact me directly. So today we're very lucky to have Dara Mendeloff of the Center for International Earth Science Information Network. She's going to be speaking to us about data and numbers and how to get meaning from piles and piles of information. So just a quick side note here, Dara is actually going to be offering a pre-college workshop for students in grades 9 and 12 on this very topic starting in March. The pre-college workshop that she's going to be offering is going to be 15 hours long and will take place over a couple of weeks in March. And it's going to give students a chance to take a deeper dive into some of the climate data information and to gain really important skills in data science and mapping in order to address real world issues. So students are going to be exploring metadata and learning to use several different analytic and visualization tools to perform data analysis and be able to communicate results. So we're going to be hosting a separate info session about that particular workshop next Wednesday, January 27th, 4 p.m. Eastern Standard Time. And we'll be providing more information to everybody as well about that info session after she is done today. So Dara's going to do her presentation, and then we'll have about 15 minutes or so at the end of the session for Q&A. We're going to be using the Q&A box today. Don't feel that you have to wait until the very end to ask your questions. If you do have questions that come up throughout, feel free to type it in the Q&A box, and we will definitely do our best to get to all of those. So without further ado, Dara, do you want to go ahead?
Thank you, Cassie. Hello, everybody. I'm going to share my screen. All right, so good afternoon. The title of this session is Climate Data, the Numbers Behind the Numbers. But don't be scared, we're not going to talk too much about numbers, but more about the meaning behind all of this, big data. So in an overview of the session, we're going to talk about this thing called data science. It's growing up so fast, it's a buzzword, but what do you really want to know? What do you need to know about it in order to make sense of all of these topics that are being thrown around? Climate data is also a buzzword, but is it accessible to everybody? Do you have to be a climate scientist in order to work with it and understand what that information looks like? I mean, the Earth is being monitored all the time. Do you have access to the information? Yes, you do. We're going to talk about that. Where can you find that information? And also, which numbers should you be paying attention to? What are the authoritative data sources? There's so many different creators out there. And in the climate world, we do a lot of modeling and forecasting. And you might even notice when you watch the weather, there are different models. And you don't really know what's going to happen until, whether the day of that storm or something, because those models are projecting different forecasts. So which one do you pay attention to? And data science tools. So what are the tools that are out there? Do you have to be a programmer? No, you don't have to understand Python. We're going to talk about it, but you don't have to be a programmer. There are a lot of different interfaces that you can engage with this information and do all the analysis that you need to. Well, some of it. And we're also going to talk about how you can integrate this information with other types of information, like where people are. So how do people relate to climate and changes in the weather? So when we commonly think about climate and weather, we think about temperature changes, precipitation. We have extreme weather events. We have an extreme drought right now. That's all related to what's going on in our climate. As well as, so we're looking for our, over a long period of time, what is changing, right? So extreme weather events, we know those are extreme because they're not happening every day. And in the history of hundreds of years of pattern that we've been able to observe, they're little outliers. So what kind of tools can we use to identify outliers? What is an extreme value? And so, right, we're talking about big data. This is NASA. This is Elon Musk. This is satellite imagery that's capturing information about what's going on in the Earth and the atmosphere all the time. Different types of resolution. So what do we mean by high resolution? And so the basic kind of skill set that we're going to talk about is descriptive statistics. Your average, your deviation from the average, your minimum maximum. How do you identify in these big data sources what those basic stats are? Because that's kind of, that's where we want to start. So a little bit of background about where I work. CSIN is a data center at the Earth Institute. And we look at how humans interact with their environment. So where are people living? What are they doing there? Who is vulnerable to these different climate change activities? So here's an example of using census information to map out where people are living, the housing age, and how people have migrated over time. I realized I have many more slides, so I'm going to go through this quite quickly. Infant mortality rates as an indicator for health and poverty, impoverished conditions. The human footprint, where have people imprinted on the Earth in terms of development? CSIN hosts a NASA DAC, a Data and Application Center, which is called CDAC. It's the Socioeconomic Data and Application Center, and we provide a lot of that information through web services. So you can go to this website and correlate things like the Environmental Performance Index at the country level with PM 2.5, which is correlates with a proxy for air pollution, the human footprint, and that infant mortality rates. And you can correlate these different sets of information at the global scale. You can zoom in and out and observe patterns. CDAC also hosts a hazards mapper, which you can use for free to do some analysis with population near different hazards. In this example, we're looking at nuclear power plants and people in a certain radius around those nuclear power plants. So CDAC is not the only data and applications center that NASA hosts. There's several others. If you go to that CDAC website and go to other DACs, you'll see there are plenty of other sources of information. So all that satellite information that we're going to be talking about comes from those centers. A little bit of background about GIS. So I'm a geographic information specialist. I like to make maps. And so when we think about data or spatial data and making maps, we're talking about these two things. So the where, which is in this case, boundaries of states, and the data. So the data is really just a table of information. And it's structured here with rows and columns, rows being your states and the columns being how you describe that state. So we're looking at this column, population for the year 1990, and we can highlight that information in this map in the bottom right. So every state is just symbolized with a color representing the value in that table, right? So when we look at the news and we see a map, an election map or a weather map, what's behind all of that is a table of information like this. So what you can display and communicate to anybody visually is all based on these numbers back here. Defining characteristics of data. So the real world can be represented in many different ways, and those numbers can be represented visually in different ways and aggregated in different ways. So here's a picture of the real world. We have a park and some human development. And so we can represent trees, lampposts, people, cars, objects as points. Very simply, these are orange points representing a particular tree. You can also use lines. This blue line is representing a river or a stream, and these green lines are representing streets or roadways. Then we can also use polygons to represent our blocks, city blocks, or building footprints. But in climate, what we're really concerned about is what we call continuous data, like temperature, precipitation, vegetation. And so that information is mostly represented as raster data, where we take this picture and split it up into a matrix of cells. They're just pixels, just like a picture. And every box, every cell gets a number depending on what it's representing on the ground. In this case, we're looking at vegetation. So how much area in this box is representing vegetation. And then, of course, you can add color to symbolize that visually so that you know the number is representing, the color is representing a particular value. So that's the basics of spatial data. And so one example of how I have used that kind of information is in food insecurity. So we at Season recently distributed or released food insecurity hotspots. So people that don't have good access to food is highlighted. So the darker the color, the more insecurity there is, and the lighter the color, the less insecurity. So this is a map communicating that information. We have minimal, stressed, and crisis. Those are 3 different levels of insecurity. So this is a story that we're communicating. But behind that, this is the numbers behind the colors. So every cell, this is raster data. So if you look closely, this is a pixel. This box is purple. If I click on that box, the legend over here tells me that that purple is the number 3, and it represents crisis. And if I use, and there's an identify tool, I can click on that box and it tells me more information about that value. So that box represents a particular level of food insecurity, of people experiencing that on the ground. And this is an application called QGIS. It's a desktop software. We'll explore this a little bit more in the workshop that Cassie was mentioning in March. But that's the idea behind this. So once you identify something like where food security is occurring and at what levels, Here's a paper that I collaborated with Weston Anderson at IRI. This is so we're correlating the type of people and their livelihoods. So who is experiencing this level of the different types of food insecurity? So this is a different type of visualization. There's a map over here, but for every pixel that we were just talking about, you can see there's different types of people experiencing that. Another story that can be communicated is something like what happens to people experiencing air pollution, right? So air pollution is a big concern because of public health. A lot of people are experiencing things like asthma. And so in this map, we have circles at the neighborhood level that are communicating asthma hospitalization rates. And the gray map behind is looking at levels of ozone. So this is a story, and I'll show you quickly what data was used in order to correlate that. Actually, so let me just talk about the correlation. So the bigger the circle, the more asthma there is, and the darker the color, the more ozone there is. So there is a correlation between the darker gray and the bigger circles. So you can say that there is a bit of a correlation here. So where did that come from? Well, there's a data set called the New York City Community Air Survey. And here's an example of the ozone information. Move my window over. So the level of ozone, the brighter the yellow is, the more the ozone. So this is a data set that you all can access for free. And I brought this into a tool called R. R is a programming language, but you don't have to be an expert in order to learn how to use it. There's a cloud version. This is RStudio Cloud. Just a quick overview. We're going to go into this in more detail during the workshop if you join us. But so here's just some code saying, show me that map layer as a raster, style it with the color gray, and make it semi-transparent, about 20%. And then here we have the map classified a little bit differently than before. So this is a common tool that a lot of data scientists use. And I won't go into this, but this is the air quality data. Just very briefly, that map, those circles that we were talking about, there was a little bit of processing that happened in order to map them properly. So the table of that asthma hospitalization rates actually looks like this, where you have the variable being mapped, the measure of what age group, the neighborhood in which we're aggregating the information to, and this data value message is the actual rate that we want to map. And so using those tools in R, we're able to produce this map and communicate a relationship that we have observed. Okay, so getting back to that big data, Google Earth Engine is a fantastic tool. I don't work for Google Earth. I don't work for Google, but I have to say it is one of the coolest tools out there. So anybody can create an account. And once you create an account, you have access to all of that big data. You don't have to worry about downloading it, where you're going to store it, how to manage it. You have access to it. They have it stored in the cloud. So a lot of those NASA data sets, a lot of the season data sets, a lot of that information is already pre-populated for you in here. And you can search. So I wanted to look for ozone. So in the search bar, I typed in ozone, and I got the I'm not going to say this, but this is a layer, a data set from the Centennial-5 satellite. And again, there's just a little bit of code that you don't have to know how to write. There's a lot of examples that you can start from. It says create a variable for that Centennial-5 data set. Set the dates for when. So remember, this is big data. There's information being collected all the time. So you have to know how you want to filter it. So we filtered it from June 1st, 2019 until July. So that's just a month of information. How do you want to visualize it? You can choose whatever colors you want. So here's a black, blue, purple, cyan, green, yellow. And then you add the layer to the map. We're looking at the average. And then you can pick your center. So, and then in the map below, you have that huge information already pre-populated for you. Another example of data you can find and work with in Google Earth Engine is global forest change. So not just what's going on in the atmosphere, but we can also measure what's going on the ground. And so here's a nice example of, well, not a nice example. Unfortunately, there's still deforestation and forest loss going on. You can see in red and yellow, there's some loss. So the code here takes in the tree cover layer. This is the layer that we're looking at, UMD Hansen Global Forest Change for 2019. And so from green to black is the forest layer. And then there's another variable mapped on top that gives us the forest change. And then with this, you can then go in and dig a little bit deeper to do some descriptive statistics to see how much area, who lives in those areas, what's causing it, what's causing all this loss. And so in terms of who, here's a layer produced by CDAC. This is the global population of the world. It's our flagship data set. We have population, population density, which is the map layer that we're looking at here, how densely populated is a particular area, as well as demographic characteristics. So what about these people? What are their age? What's the age, sex, race, all of that interesting information. We want to know how is climate affecting people disproportionately or proportionally. So you can overlay these data sets in this tool with a little bit of code and calculate how many people and of what type are being affected. So that was just a little overview of how I use climate data, how I integrate it with other sets of information, and the type of tools that I've been using. So in March, these are the type of things that we're going to cover in depth. I'll show you how to use them. And we'll also evaluate different data sets. So there are hundreds of different data sets that you can use. How do you know which one to use? So we'll go through all the evaluation, the QA, QC, and really get into the numbers about what's the difference between a population count and population density. How do you calculate loss? How do you measure change, for example? And so that's all I have for you. Thank you very much.
Great, thank you, Dara. So for our viewers, if you have any questions that you would like to ask, whether it's about specific data sets or generally how our scientists use data, feel free to use the Q&A box. I'd like to actually introduce a another speaker here, actually, Matt Pierce from NASA. This was a super relevant session to all the information that NASA has and all the data sets that they have. And Matt wanted to join us and share a little bit of more information about the resources. And whatever we talk about during this session will also be shared on the EI Live site. So Matt, do you want to just jump in and tell us a little bit about what NASA has available for us?
Awesome. Thank you. And thanks for letting me join in today. And what a great presentation and very relevant to the work that NASA does. So you taught me a lot already. So I really appreciate it this time. Thank you. In addition to the great work that you just and access to the CDAC systems, my goal was to kind of come alongside and share with you some additional resources that are relevant to this topic and the future topics that you'll be engaging with in this series. So on the registration page, you'll find 3 links from NASA that I think are worth your time as additional exploration and additional topics to discover relevant to this subject matter. The first one is called RSET, and that stands for Applied Remote Sensing Training. And that's a platform that provides a whole variety of different modules that will, in addition to what you've learned today, use other NASA tools to do remote sensing. And it's a really seamless training. It's completely free, and we'll give you time and opportunity to explore those tools. So I encourage you to take a look at that. The second one is Worldview, and that allows you to also evaluate quite a few different aspects of geophysical data, precipitation, dust, aerosol, optical depths, snow, and hurricanes, and so on. So you get a really good worldview, just like the name says, to allow for additional exploration. And then one of my favorites when it comes to data is NASA has an organization called the Scientific Visualization Studio in it. And when many of our scientists conclude some of their work or want to tell the message of their data, they will work with, we call it SVS for Scientific Visualization Studio, to create really dynamic, powerful, data relevant visualizations that I find quite captivating. And so if you like to explore and you want to look at some of the things satellites are looking at, or if you want to look out at Juno, that's a satellite that went around Jupiter, or if you want to see some data from Pluto or other parts of the solar system, that's a great place to go exploring. And so yeah, just wanted to highlight a few resources and also mention if you're a high school student over 16 years or older, or even if you're an undergrad attending, I wanted to encourage you to think about interning with NASA for the summer, and you can fill out an application at intern.nasa.gov. But again, if you need to find me, you can always Google my name, Matthew Pierce, and NASA, and I can answer any supplemental questions about the resources we just provided or any other questions you may have about NASA. So I promised I wouldn't take up too much time, so I'll turn it back to you, Essie.
Great, thanks, Matt. So for our viewers, I've put the links and the resources that Matt has talked about in the chat box here. And NASA does really have wonderful summer opportunities. So even if you're not a high school student or undergrad watching this, if you would like to share that information, we'll also get that posted on the EI Live K-12 website. So if anybody has any additional questions, feel free to use the Q&A box. We have our data expert, Dara, here. Dara, while we wait for perhaps a question from the audience, maybe I'll take an opportunity just to ask you first. I think you mentioned a couple of great resources and reputable sites where we can get data and information. What are some of the questions that you ask yourself when you're looking at data? So if we're reading an article or we're looking at a report and we see all kinds of numbers, what are some of the questions we should ask ourselves about, is this valid? What should we be paying attention to? What would a data expert and data scientist think about first?
That is a really great question. Lots of things go through my mind when I'm hearing all these numbers being thrown around. So the first thing I ask myself or look for is, where did this information come from? When is it from? How did you come up with these numbers? So there should be a brief overview of how these predictions or forecasts came to be. So always look for, how did you come up with this? Because all numbers should be traceable, right? We all know that science has a process, so it should be reproducible. And I'm a data geek, so I want to reproduce a lot of these things. So I also always look for the source. And I'll end up at some NASA resource and download the data myself and say to myself, okay, how do I reproduce this? What tools do I have that I can get that same number? And if I can't get that same number, why is that? What decisions did they make that might be different? And a lot of times, it's good to have all of these data, but as you'll see, once you start working with that data, there are decisions that are made along the way. Whether you filter for greater than 50 or greater or equal than 50, there's a difference between the two. You're gonna include one value or not on that equal than or greater than. It's very simple, but those decisions lead to bigger decisions that are made. So I have lots of questions like that.
That's great. Thanks. In terms of, there's so much information now, and we're still sort of in there's so much information about COVID. And so I feel like, there's so much information being produced. How do we pay attention to all these different things? And one of the things that keeps that I've seen people wonder, or people have asked me, and students have asked, is there a way to connect climate data with COVID data? And if there is, what are some of the questions we might explore, and what are some of the sites or sources that we might use?
So I've been really fortunate to be a part of a project with Maria Duquasser and Pilar, I'm forgetting your last name, but a group of folks at the E3B lab, which is an eco-epidemiology lab. And they're interested in vector-borne diseases like ticks and mosquitoes, and how that affects people that are moving in different areas. And COVID has kind of illuminated this opportunity to look at how people are moving differently because of COVID. Are people staying put, or are they moving to, what do we do for fun? Or what do we do to get outside? Are we going to restaurants? Are we going to parks? So how are people moving depending on, the weather, or, these, depending on what? So I think that's one interesting thing to look at. Also in the light of climate change, a lot of people have migrated. People are migrating all the time. Areas are flooding, islands are disappearing, forests are burning, people are moving. Where are they moving to? Yeah.
That's great. And
also, why is COVID happening in certain places? Are all these different viruses and diseases? So public health is a really interesting thing in order to related to climate. Yeah. Sorry, Cassie, go ahead.
No, those are all great, great points. And I've just shared the links to Maria's lab, and Matt has also just shared sort of seeing COVID-19 from space, which is another great NASA resource here. So I don't see questions, but if our viewers have any last minute questions you'd like to ask of while we have our expert here, feel free to type it into the Q&A box. And Dara, perhaps one last question from me to you is, how important is it to communicate data? We have worked on projects where we talk about the importance of communication and making it accessible. And a huge challenge to communicating data is that it is challenging, and because many of us have perhaps don't have data science kind of as our background, or we didn't particularly go into statistics or anything like that. So just how important is it to communicate data and make that information accessible to individuals who don't necessarily come from a numbers background?
Communicating information is more important than ever. I think that's even more important than knowing how to code or press a button in order to run a model. I think being able to talk with other people. So data science is really not just coding. Anybody can, code and run that. But in order to make change in the world and in our communities, you have to be able to communicate to business owners, to politicians, to other types of managers, to those people collecting. So Matt and I both work with data, but we're in different sides of the spectrum, right? So I need to learn how to communicate with him about, what data sources he has and how can it benefit my research. So communication and being able to work in a team, I think, is even the number one most important thing. And all that leads to, policy change and what actually happens in the evolution of what we need to collect and filling those gaps, and to address things that need improvement. So things like food insecurity. If I'm unable to communicate that this is a hotspot area, that people are experiencing extreme food insecurity here, they need help. If I'm unable to communicate that, then we've all failed. So, and then we can even ask, why is it happening, right? So I need to communicate with people on the ground and say, this is a hotspot, but let's figure out what's contributing to that. So being a team player is really important.
Great, and that's a great reminder and a great place to wrap up. So if our viewers, any last minute questions, feel free. We have the expert here. But if you do have additional questions that you think of later on, feel free to send that over to me, and we'll be sure that gets answered. And this recording will, along with all the resources that Matt has shared and resources that Dara has mentioned, will go up on the EI Live K-12 site, and everybody who's signed up for this session will get a link to that site. And if you are at all interested in in our pre-college workshop, where Dara is going to be working with high school students and really digging into the data science, the analytics, and the tools, join us for an info session that's being held next Wednesday, January 27th at 4 p.m. And we'll also include that in the follow-up email. So Matt and Dara, thank you so much for joining us today and for taking the time to do this. And we will see everybody else, hopefully at a future EI Live K-12 session. All right, and enjoy the rest of your afternoon. Bye, everyone. Thanks.